So the test that we made is a way in which to tell how much immunity somebody has against a particular virus. And our inspiration for trying to develop this test was to try and figure out how protected were people from the SARS-CoV-2 virus, which is the virus that causes COVID-19. And so when we were trying to figure out a way to tell how much immunity anybody has, whether they were previously vaccinated or previously infected, what we really wanted to identify and measure the levels of was neutralizing antibodies. So neutralizing antibodies are pretty special in that they don't just bind to a virus, they actually prevent the virus from infecting our own human cells. And so that's what was really key about why we wanted to measure the concentration of neutralizing antibodies. So people know of lateral flow assays because this is what COVID antigen tests are, but also they've been around forever. The most famous example being the home pregnancy test. And so we were able to get this neutralizing antibody measurement test down into a lateral flow format where something really easy, like a little cassette like this, could say whether or not you were not yet vaccinated, and so we're missing a line right in the middle here, or effectively vaccinated with high levels of neutralizing antibodies, and so that middle line is here. And this is actually my blood samples that were saved from before I got first vaccinated, and then a few months after I completed my full series. As an oncologist, my patients, they are at a baseline immunosuppressed, just as immunosuppressed or even more than, say, elderly folks or people on immunosuppression. And it's really important for these people to know whether or not they've lost immunity from that previous infection or that previous vaccination. And so this was the real reason that I, as an oncologist, wanted to develop these tests. But I think also, too, in the general public, people have a right to know how protected or how immune are they to the SARS-CoV-2 virus. And more broadly, if we could extend this to other viruses, whether that's pneumonia infections or chickenpox, etc., I think this technology and the platform it's based upon has a lot of potential for other uses in public health.